we're going to take a look at graphing quantitative variables. And in this first video on this, we'll start by looking at things like the shape of the data that we look at, what we describe it with the measure of a center of the data, and then also we'll take a look at the variability. We'll take to first step into graphing by looking at dot plots. So as we should recall, quantitative is usually a number. Not always. I mean, sometimes sometimes we'll use a number to describe a categorical variable as well. But if we have a number, it's usually going to be quantitative, and we look at things that are either measured or counted. We can count categorical ones, but we can, when we measure things, or if we're looking at things that order matters for how the numbers are lined up, if we use it as a number itself, a quantity, so we want a quantity for this, then we're going to have a quantitative variable. Now, there's two types of variables that we'll be looking at. Now, most of the mathematics we've been doing up to this point has been continuous mathematics. When we plot points on a graph, we connect them. That continuous graphs are connected, whereas discrete graphs have gaps between them. And so statistics is starting to look at the mathematics behind things that are often discrete. So discrete are countable values with gaps between them. Now, when we talk about a continuous variable, it can take on any value on a certain interval. Like if we talk about from 1 to 10, not only can take on the counting ones like 1, 2, 3, 4, but it also can take on a number between it, like 3.2 or 7.8. So when we look at the continuous variable, it can take on any value on an interval. This usually means we have connected graphs. Here there's gaps between numbers. When you look at the graph, it's connected. So you kind of take the dots and you fill them in by connecting them. Also, we'll just use that test that if you pick any two numbers, there's always a number between them. So if we pick, for instance, 1 and 2, between them is 1.5, and then if we go further and we say 1 and 1.5, there's 1.3, and you can just keep going. There's always a number between them for a continuous variable. Now, a distribution we've talked about before. This tells us what variables are used and how often. What values are used when we're dealing with this variable, what values are used, and how often. Now, we're going to start describing what these distributions look like. We're going to look at center, variability, and shape. So when we describe something, that will help us understand what is some information about that distribution. So sometimes we'll talk about that as location and spread. Now, spread can be a difficult word to use because sometimes people will just give the minimum minus the maximum. We're going to specifically use for the center. We're going to start with mean and median as our primary ones that we look at. That will tell us where the center of our graph, like here, the mean is right in the middle, but it means somewhere in the middle of the data is our center. Variability, what this will tell us is often listing the minimum and the maximum. So list the minimum and maximum for now. And later on, we'll look at other measures of variability to help us out. But we'll start with just listing the minimum and maximum, not subtracting them, but what the actual numbers are. And then the shape, we want to take a look at these different possibilities for the shape. Now, I'll start with symmetric. Symmetric shape is, this is that idea of being a mirror image. So if we look at a graph that's symmetrical, what you see is a mirror image on the left and the right. Okay, so if you were to fold it right down the center of the line, it would fold over approximately right on top of it. Now we're talking about symmetric being approximately like this, not necessarily precisely, because data is sometimes gives a rough estimate. So if it has this general shape of the left and the right being similar, the same, that would be symmetric. Now right skewed, when we look at this, we want to think of a right tail. So what we see on this one is that you have the mountain of data on the left side, and that's why people get confused, because the right skewed means that you have a right tail. So the tail is on the right side for it. Okay, so sometimes this will be called positively skewed. And that's because the skewed part of it, the tail, is going toward the positive side. Whereas left skewed, again, the tail will be on the left side, and then the mountain of data will be toward the right. So we put, for left skewed, we say left tail. And then this would be negatively skewed. In order to see that the tail is skewed toward the negative side. Now, let's take a look at what you might look for when you're looking at graphs. So sometimes it isn't so clear cut. So what you want to look for to be clear are clear peaks in the graph, clusters of data on the graph, and then gaps in the graph. That will help us describe what's going on with the data. Now, with the peaks in the graph, if there's one peak, that's called unimodal. If it's bimodal, there's two peaks. And then if we go more than two peaks, we call it multimodal. Okay, now once we see this, we can use that information to describe what the graph looks like and help us understand the shape. Now, one specific type, and this is a symmetric graph, so I'm going to put above this one, this is symmetric. So it would fit into the symmetry category, is uniform distribution. A uniform distribution is where the frequency of each value is about the same. So an example of this is if I were to survey baseball teams to see how many people are in their dugout, how many players are in the dugout, it would be about the same because they're only allowed to have a certain number of players on their team, say in the professionals. So that would be something that would be fairly uniformly distributed. Now, the shape of it, and I'm going to do a dot plot for this to kind of help us see what a dot plot is coming up. So for this one, it would be something that if you had every one of your things that you're doing about the same, so all of these are just about the same, kind of straight across for the distribution, no tails anywhere on it, then that's uniform. So approximately uniform distribution. So that's what you look for. Remember, when you look at a graph, it's what do I see? I see it pretty much straight across. That would be a uniform distribution. Okay, last piece of vocabulary here is an outlier. So an outlier is a value that falls outside of what we would expect or what the overall pattern is. So if it falls, we're in a place we wouldn't expect it to because of the rest of the data, then we call that an outlier. Now let's look at an actual type of quantitative data graph. We'll call this a dot plot that we'll start with for this. A dot plot, this shows each value as a dot above its location on a number line. This would be a discrete graph. So let's take a look at an example of what this could look like. Okay, so for our graphing instructions for this, we're going to do an example. We're going to draw a horizontal axis for the quantitative variable, so just a number line. Scale the axis. Now you don't have to, in this case, start at 0, start at a convenient starting place, but then use uniform units in order to give the scale for it, equal intervals, and then plot the values, stack if it's a repeated number. So an example would be, how many siblings do you have? I did a survey in my 5th period class, so 5th hour data. The 5th hour data that I have is that when I did this, and I'm going to start my graph here, so here's my number line. Okay, and I'm going to start this with, I'm going to go 0, 1, 2, 3, 4, and the maximum somebody had was 5 on it. So the number of students that had 0 there was 2 of them, so just 2 dots here. The number of students that had 1 sibling was 8. So it goes up pretty sudden, 2, 3, 4, 5, 6, 7, and 8. That was matched by the number of students that had 2 siblings. There was 8 students who had that as well, 3, 4, 6, 7, and 8. I want to try to keep them equal intervals going up so that the height for 8 looks the same. And then for 3, it went down to 4, so 1, 2, 3, and 4. Then for 4, it went down to 2 people had 4 siblings, and then there was only 1 student in class that had 5 siblings. So if you look at this data set, it kind of shows us that it goes up fast on this side and then kind of tails off. So if we were to, oh, this is 25 students. Okay, 25 students here. So if we were to describe this data set according to shape, this looks like it's right skewed, okay, because it's got a right tail. So right skewed for the shape. Now we want to do the center of it. I'm going to use the median. If I count in, there's 12 and 12. If I get the 13th student from either direction, so the 13th student, since they're in order from either way, is in the 2 category. So my median measure of center here is going to be 2. And then that's my measure of center. Now, if I'm looking at variability, I'm going to list the minimum. The minimum is 0, and the max is 5 in this class. Other classes would have different data sets, could show up differently. So what we've done is we look at quantitative variables. We talked about, first of all, if we do quantitative variables, we define some terms, we looked at information about that, and then what about shape of graphs? Talked about the shape of it, we talked about the measure of center, and then we also talked about variability. Once we did that, we came up with a specific type of quantitative data graph, and we call that a dot plot, where we plot points for each piece of data, which helps us see what the shape of the data looks like. So remember, a graph helps us see what does the data look like, and from there we can start talking about some information that we can conclude from looking at the data, talk about that information, and also in the future we'll be able to compare it to other data sets.